Hello everyone, welcome to the JavaScript Exchange. Hope you're all keeping well and can hear me okay. It's our second event, virtual of course, just launched just over a month ago. So the agenda for this evening, I'm just going to give you a quick overview of essentially who we are, and then we'll crack on straight into the talks. So the JavaScript Exchange, you may not be aware, is part of a much larger community. As you can see there, you might be aware of the DevOps-Exchange or Docs, which is spread up and down the UK and into Europe. So JavaScript Exchange being the latest arrival to that community, hoping to replicate the success of Docs and continue to build and put on these events for you guys. So in order to keep in touch with us, of course, you would have found us through the Meetup page. So you'll be following that, and that will keep you pretty clued into everything coming up and all the speakers and things that we have lined up. But we're also on YouTube as well. So this presentation will be recorded. And also we're on Twitter. So at JavaScript_X at the top there. And then on LinkedIn, of course, as well. So the plan for this evening, we're going to be keeping this interactive. So with regards to the Q&A, you should find a Q&A button at the bottom of this webinar. So don't be shy, chuck your questions in that. The speakers will have an opportunity to answer a couple of questions at the end of each talk. So yeah, don't be shy, put your questions in there. So the speakers we have lined up for you this evening, we've got 3 talks, which will be starting in a second. First, we've got Jonathan Fielding over at RVU, which also includes companies such as Uswitch, Money, Bankrate, etc. It's all around being eco-friendly with JavaScript. We've got, following that, Chris over at Vonage, dead simple APIs with OpenAPI. And then finally, we'll be wrapping up with Giorgos over at Bet365. We'll be discussing, obviously, measuring web performance with user-centric metrics. Linux Recruit is our sponsor for the JavaScript Exchange. It's also where I work. So I'm a recruiter within the JavaScript world and have been for some time. Obviously, this couldn't be possible without the backing of someone, and that someone is Linux Recruit, to find speakers, do all the background work in terms of organizing and finding venues. So yeah, big shout out for Linux Recruit for putting this together. But please don't bear in mind that Linux, ignore that. Very much involved in the world of JavaScript, as I mentioned. On that note as well, the two key people within the world of JavaScript and the wider development are myself and Jess. Contact details there. Obviously a little bit of a strange time at the moment, but we're always here for a chat. So whether you're looking for a new position or looking to build your teams, please get in touch. And finally, if in the future you'd like to speak at one of our upcoming events, please get in touch on the email provided there. We're always looking for new speakers on a range of subjects within the world of JavaScript. So if you feel like giving it a go, or know any venues or anything like that, then please get in touch. So without further ado, I think we'll start with our first talk, which is with Jonathan. So welcome, Jonathan. I'm just going to stop sharing my screen now if you'd like to take over.
Cool. Cool, thank you. So I'm just going to, there we go. So I'm just going to increase that a bit. So hi, I'm Jonathan. As Tom said, I'm a lead engineer at RVU, where I spend a lot of time working with financial services, working with the Money and Uswitch brands there. So this talk is being eco-friendly with JavaScript. So I do want to say this talk does feature a bright light as part of some of the demos. So it's just behind me. It will also unfortunately affect the focus of my camera, because it will try and refocus every time I turn the light on. So many people have made suggestions of what this talk is about. There was an interesting one around writing JavaScript that required less CPU cycles. Unfortunately, I'm not that smart. to JavaScript-powered robots that clean up the plastic in our seas, I don't have that many resources. And they would make amazing talks, but today what I'm going to do is focus on talking about how you can use JavaScript to reduce your own impact on the environment. So to set the scene, 3 years ago, I moved into my new house. It was a new build. It didn't look like this, but you get the idea. And it's had well insulated, etc. And I wanted to make sure that as a family, we were reducing our carbon footprint. So one of the key areas I saw of growth in my carbon footprint was my electric usage. Because as my kids get older, they're using the TV and they're using computers, especially at the moment when we're all at home. So they're doing their schooling downstairs and on the computers. So I wanted to reduce the electricity I was pulling from the grid. So to start with, we need to understand our electricity usage. So when we build products, we use data to make our better decisions for our users. And when we want to start to make our house more eco-friendly, we should also be using data because we don't want to be doing things unnecessarily, right? And the first point we have is our electricity usage data that can be provided by our utility company. So I use British Gas, partly because partly because they're the cheapest when I originally joined with them, and they seemed quite good still. And this was taken from the dashboard. So in 2018, you'll see that my energy usage ranged from 130 kilowatts to almost 500 kilowatts. Note that in October that year, I had solar panels installed, and that is the reason for the drop. So that allows us to understand our current usage and allows us to set a baseline to compare against. And set a baseline in place is to identify devices which contribute to most of our electricity usage. And there are many devices that allow us to monitor how much electricity a particular device is using. The most common being energy monitors and smart plug sockets. So the way an energy of a device with a clamp, this allows them to read how much electricity is passing through that cable. An alternative is smart plugs. So these sit between your main socket and the device, connect to your Wi-Fi and provide energy data via an app. So here today, actually just down here, I have a TP smart plug, and we're going to write some code to actually interact with that. So this is a Node REPL built into my slides. So what I'm doing is I'm using a TP-Link Smart Home API library, creating a client, and then just trying to search my network for the device. So running this code, I've got the device info here, and you can see I found a smart plug socket. And I've imaginatively named it plug. Let's stop that. Cool. Now, this particular model allows me to get energy usage. So I've updated the code here to when it finds my plug socket, it calls to get energy usage. And what it's going to do is, in real time, it's going to get the power usage I'm using. This measures it in milliwatts. And then every second, we're going to update that. So if you'll see is that currently it's using no power. I'm going to plug in a dehumidifier because they use lots of power. And as you can see, immediately I'm starting to get increase. So with my dehumidifier, actually, it starts off quite low. It's using more power. And when it warms up, it starts using a lot more power. To make this more visible, we can set up a light bulb to alert us if we're using a significant amount of power. So I've got a light bulb here behind me, and I'm going to unplug the humidifier and run this code. Okay, so now it's turned green because I'm currently using no power through it. But if I plug in the dehumidifier, it's going to turn red. And that's because what I've done is I've captured the bulb and the plug. And then when I've got the bulb, I'm telling it to get the energy usage. Then in here, if I'm using greater than the 5,000 milliwatts of power, it's going to be set to red, otherwise it's going to be green. Cool. And aside from real-time usage, I'm going to turn that off. Aside from real-time usage, we also wanted to understand how much power we're using over time. So this device also has a API to get statistics of number of days. So I used this particular model quite a bit last November. So I'm going to do it here. And what you can see is I have a number of days here with the amount of electricity usage in watt hours here I was using each day. As developers, we like to visualize our data to understand usage over time. So here, what I'm doing is I'm using a JavaScript library called Urvi. Urvi is a command line library for rendering graphs. So we're going to render a bar graph. So you can get the data from our smart plug. We're going to then get 7 days of data because I haven't got much room down here. And then we're going to render that as bar data by mapping through the data into the correct format and outputting it. So as you can see, I now have a graph that's output as well. So having visualized the data, we can start to get an idea of the kind of usage patterns we have. And using multiple smart plugs in this way will allow us to understand how much power individual devices are using. So we've got some data. The next step is reducing my electricity usage. Having identified devices that are using excess amounts of electricity, we can now look at optimizing their usage. Have I already bought smart plugs? I found there's an easy way to do optimization. So I was doing this in summer, so I had a lot of fans around the house. So I decided that I would optimize them so that after an hour they'd turn off automatically, because especially at bedtime, I'd turn it on before I went to bed, and then it would be, otherwise it'd just stay on all night. So similar to the code before, we are finding the device. We're going to turn it on. And then after 6 seconds, because I'm not expecting you to sit around for an hour for this to work, it'll turn off. So it's on right now. My dehumidifier is on right now. And in 6 seconds, my dehumidifier is now turned off. I would have had a fan, but it was a pain to carry to this room. Maxing out the fan at an hour, it did help prevent us leaving them on necessarily. But interestingly, our fans have actually just lasted longer as well, because we're not leaving them on for as long, so the motors don't burn out as fast. Another way in which we can reduce electricity usage is to avoid leaving lights on in empty rooms. So I wasn't able to set up a demo for this, but what you can do is you can have a motion sensor that when no one's in the room, you can turn those lights off automatically. Kind of like you have in at the office, but a bit more homebrew. So there's only so far you can get with trying to optimize your existing usage before you need to start thinking about how you can get more eco-friendly electricity yourself. So we reduced it as much as possible, and then we decided to add solar panels to our house. So for those who haven't been involved in solar panels, what you normally do is you have your solar panels on the roof. They generate DC, direct current electricity, so they are attached to your solar inverter, which will then convert that to the safer AC electricity, which is what the main uses, and puts that into your main fuse box. That will then be responsible for diverting around the house. So by default, it will go to your house load with any extra electricity going out to the utility meter. In some cases, you might have a battery to store any excess electricity, so it stores there before it goes to the grid. So we did do that. We had a Tesla Powerwall installed, and the cool thing about that is it provides an API with real-time energy data. So all this is just a normal REST API. I've proxied it through my through a broker to make it available to the internet. But what you'll see is we have, it's going to give them the aggregate information for grid, solar, battery, and load. So if you run this code quickly, so what you'll see is in the API site is how much power is pulling from the grid. So I'm currently pulling that much power from the grid. Then you can see that right now I don't have any electricity coming from the battery. The load, this is how much electricity we're actually using right now. This here is in kilowatts, I believe. So earlier we talked about using a light bulb to show how much energy is being stored by one device. Now we can do it for our entire house. We have the bulb like we did before, so we're going to find it, and then we get the energy usage from there. So what we see is right now my house is being quite eco-friendly. Like I said, it's currently using 0.3 kilowatts, and actually that's coming from my solar panels as well. So I'm currently running off the grid, which is nice. Aside from understanding the current power flow of the property, you can also use the API to see the current battery charge level. So there's this state of energy endpoint, and just run that, and I can see my battery is currently at 100%. We can therefore make our script smarter by taking into account whether the current load can be sustainably managed overnight, because this would encourage me to turn things off if I need to. So in this example, what we've done is I know my Powerwall can store 13 kilowatts of electricity. So I work out how much power I have based on the percentage that I get back from the Powerwall broker. Then I work out the number of hours until 7 a.m. because I assume 7 a.m. it'll be light, start to generate power again, and then work out how much power I'm using versus the hours left a day, and then set it to green. So right now I'd expect that to be green. Cool. The next thing, taking my electricity with me. So around January last year, our car started failing, and as a single car family, we needed to replace it. When looking for a new car, we decided to explore the practicality of getting an electric car. Our biggest concern was we would not be able to achieve the range we needed for some of our longer journeys. However, when we did some research, that wasn't the case. Like this is a journey from Calais down to Disneyland Paris, and my car could certainly make that journey. We only stopping once to charge, which makes me happy. Having done our research, we settled on purchasing this in Leaf, and within a days, I found it had an API. Win. So I'm going to run this code before I explain it, and the reason for that is the API is quite poor and quite slow. So we have this car wings JavaScript library that creates a connection to the North Europe region. Then what we need to do is log into our car and then request the current start charging status. Now my car isn't currently plugged in, so we'd expect we'd expect it not to be flagged as charging. So it's currently charging 0, about 41% battery life, and so that's the timestamp for right now. Cool. And aside from checking current charging status, we can also tell the car to start charging. So the car, like I said, the car isn't plugged in, so I'm not able to charge the car right now. But it's as simple as telling the car to charge, and then this code here just verifies that that it's still charging. Now, where it gets even more interesting is we can start integrating different things together. So the Powerwall API that we used earlier can be used in conjunction with this with the car charging. So what we can do is we can say get the current solar energy, and if the percentage is over 80, we can start charging the car. This means that I am only charging the car when I have excess electricity, rather than always end up accidentally charging from the grid. So back to the data. Let's have some results. So earlier we talked about how much power I was using per year. So before I started this optimization, we were at 3,782 kilowatts per year. Then in 2019, I was at 2,474. I unfortunately couldn't get a newer screenshot because problems with the British Gas website. And that's a decrease of 1,308 kilowatts hours. And what's worth flagging is, in that time, I actually increased some of my electric usage because I bought myself an inflatable hot tub and put it in the garden, and they're quite power hungry. But I was able to optimize that so that it was using power from the solar panels mainly. Okay, that said and done, what were the next steps on my journey? So there is significantly room for what I can start more. Yeah, there is significantly more I can do to improve my energy usage further. So the biggest being related to when I end up putting excess electricity to the grid, because when I pull electricity from the grid, obviously the energy gets lost as it travels. So it's better to use the energy that I generate myself. And one solution I've been playing with is predictive behavior based on outside data sources, such as the weather. So Dark Sky provides a really good API for this. Unfortunately, that's probably going to close down next year because Apple recently bought them out. But what we can do is we can call their API, and it will give us information about the weather. So currently clear throughout the day. Yeah, so it's going to give us all the weather information. So with this data, I believe what we can start doing is optimize our energy use much further by telling it to save power when we know there's going to be rain. So in summary, technologies exist to help us become more eco-friendly. Solar panels, electric cars, even just smart plugs, which allow you to reduce your an individual device from using power. And it's very easy to actively monitor your house these days, gather this data. And the biggest thing is changing our habits. So don't put the washing machine on when you don't have excess power, for example. The biggest challenge I think we have as a society though is all these things are distinct systems. The Tesla Powerwall is distinct from my solar panels. My smart plugs can't talk to that either. My car doesn't know about anything other than it's getting electricity from the grid. So deeper integrations are not possible for the average consumer. So as developers, we can use a little NPM magic to overcome this, and we can start tying everything together. And I'm hoping that there's more startups that pop up and help do this sort of thing, like pulling all these different things together so we can have more consolidated effort to reduce our eco footprint. So that said, I want to say thank you to all these people who provided photos on Unsplash, and definitely thank you to my wife, who has put up with me demoing these slides way too many times. Firstly, when I gave this at a conference, and then I was making her watch this through Zoom the past few days as well, so I could practice working remotely. The end.
Thanks, Jonathan. That was brilliant. Great talk. I think we'll move straight on to Chris now over at Vonage. So, Chris, if you want to take the reins and share screen, that'd be great.
Okie dokie. Let's get things shared. That should be there. Okay. So, yes, as mentioned, my name is Chris Tankersley. I'm a developer advocate at Vonage, and I work on our Nexmo API product. We're a communications platform API, but my actual job is working for the SDKs for the APIs. But I wanted to talk today a little bit about a project that we've been involved with for the last couple of years, which is an open source project called OpenAPI. And as we move, especially in the JavaScript world, building single page applications and client rich applications, the having a nice, well-functioning, well-documented API is almost a must for any developer. So what exactly is OpenAPI itself? Well, they describe it as an API description format for HTTP APIs, which is a kind of fancy way of just saying it's a specification. OpenAPI by itself has a large ecosystem around it, but it primarily is just a specification for documenting your APIs. And that is actually really, really useful, even if you're using it just for documentation purposes. But with that large ecosystem around it, you end up with a lot of tools that can help you as a developer actually build out and maintain APIs, as well as get those APIs out to end users. So the description format itself does a couple of main things. One is defining the endpoints that are actually available. So you can say I have a users route and a post route and a post/ID route. And if nothing else, that gives the users the ability to look and see what endpoints are available for you to use. Since OpenAPI is very RESTful, it does also let you document what verbs can be used. While it primarily caters to REST and REST-like APIs, you can build things like XML APIs with it. It's not really super useful for SOAP, mostly because that has a WSDL, which has its own kind of descriptive format. But anything that's pseudo REST-like, even if it's down to just I accept plain old get and post for normal things, you can actually say for the user's endpoint, I will accept a get and a post, because a lot of times we'll get a list of users, and then posting to an endpoint will generally create a new one. But to user/ID, I will only accept a get and a put for retrieving a user and updating a user. So that way users can expect what verbs can actually be used. One really important thing is knowing what responses actually look like as they come back. And there's actually things built into the specification that make it easier to have a consistent response throughout the endpoints. So you don't necessarily have to run into the situations where if I do /users, it'll return a user object that looks a specific way. But if I do /users ID, there might be fields named differently or things like that. If they are named differently, cool, at least they're documented. But there are ways that it actually has things built in to help you reuse those responses and those models to provide a more consistent experience. And finally, it allows you to document what kind of authentication methods you support. As APIs grow, you may have one that doesn't have any authentication method. You might have some very simple ones that just do a simple token in the query string. You might have things that need something like a JWT or some other token in the headers, or just even a dual key like a secret and an API key. You can document all those things, and if you have a very complex API like we actually do, depending on what format or which endpoint you're hitting, you might have multiple authentication methods. So you can help document that and help guide customers to know what sort of authentication they need. So why exactly do you want to use OpenAPI in that case? If it's mostly just a documentation standpoint, what kind of benefit do we get out of it? One thing that we use quite heavily is the fact that it allows us to describe our API in a very simple way, just like you would with like configuration as code with things like Ansible or Puppet or other tools like that. The OpenAPI spec is basically two formats. It's a YAML format or a JSON format, and you write it all out in a plain text document. There's no special programs you need or anything like that to maintain it. We ourselves actually push them to a GitHub repository, so you can actually go on GitHub, pull down any of our API specs, and inspect them yourself. But we use them quite a bit for actually adding new examples, making sure we have good examples in there, but also being able to see API changes. So as our engineering department makes changes, I can actually see those Git diffs come down the pipe and know what we have to change in our SDKs. So even without knowing any of the actual physical code changes we make, this is much easier to parse than actually having to get access to some actual code base and maintain knowledge of that code base as they add new endpoints or as they add new parameters, things like that. One thing you'll notice if you look at ours, we actually have a lot of change histories for a lot of our APIs. A lot of that is examples, because examples help us also understand what are supposed to be coming down, and then we can utilize those later on. The big part about OpenAPI, though, is a lot of the tooling integrations. OpenAPI is based off of an older specification called Swagger, which is still technically around. It's more of a commercialized version of this. But the OpenAPI spec is a very mature, very robust specification. And because it has been kind of battle tested throughout the years, it's very easy for people to understand and get familiar with. So you end up with a lot of tooling integrations around it. And it's not just simple things like just making sure that the format is correct. There are things that allow you to turn it into other API spec things. So if you're using a tool that doesn't understand OpenAPI, there are things that can turn them into things like API Blueprint, which is an older, I think now less used API spec. There are linters that tell you how well things are working. There are mock servers you can use for this. There are ways to generate code, which I'll talk about here in a little bit. But an entire ecosystem is built up around this to make our development lives easier and make some end users their lives easier by being able to consume and use these specs. If nothing else out of OpenAPI, the documentation generation is a huge, huge win, especially for end users. So even if you don't use it to generate your own code, you can take the OpenAPI spec that you create, you can run it through a various suite of tools, both supported as given to you by OpenAPI or by third parties, and generate really nice documentation, both technical documentation and end user documentation. One of the default OpenAPI generators that's out there for JavaScript will actually give you one of those nice little live demo API documentation things. So like it'll say like get/users, you give it your key, and you click go, and it'll actually run a real API request as part of the documentation. So you kind of get that almost for free by just building out your specification. It's really easy to write tools for it as well. So this is our developer documentation at developer.nexmo.com. So this entire page is built completely off of the OpenAPI spec. So where it says like create an outbound call, that's actually a description in our OpenAPI spec. The URLs for like post and then the actual full URL there for creating an outbound call, all completely pulled from the spec. So whenever we have changes to this, we update the spec and then send it through our CI pipeline. And as part of that, we get free documentation out for that. To the point where we actually supply this as a free open source tool. It's a completely white box product. It's our OpenAPI spec renderer. So if you just want to be able to provide documentation, even just documenting it in the OpenAPI spec, you can very easily through various forms get a lot of documentation for your end users. So if all that sounds kind of cool, the nice thing is you can start to sit down and start designing an API without anything special. So all OpenAPI itself is either a blob of JSON or a YAML file. I personally like the YAML file myself. It's a little bit more verbose, so you can kind of see what's going on with it. The JSON works just as well. It's just a little bit taller, especially for examples. But here's actually a sample API. You can open up a text editor and immediately start editing. I don't really like to do this. You have to have a lot of domain knowledge of how the OpenAPI spec itself is built. But like I said, this is a fairly mature specification. So there are tools that we can use to help build these things out. So this is actually Stoplight Studio. This is a tool provided by the folks at Stoplight. They have a couple different things that work around the OpenAPI spec. But this is actually their kind of like little IDE for it. I really love this tool, if nothing else, for just helping edit these files or just kind of skeleting out APIs, because I can immediately open this up, start putting in some paths, start putting in some things, and you end up with an API and a specification document that comes out of it. There's no vendor lock-in with this. Literally, its output is just a YAML or a JSON file at the end of the day. You can wire it up to GitHub. You can push it elsewhere. You can import other things into it. So it's just kind of a nice icing on top of everything else. But there's three main sections to Stoplight Studio. The main section is the actual specification area, where you can put in the description of your API, what the route is, what your default URLs are. So here we can see we've actually got to get a post lit up, but I could actually add, put, patch, whatever else that this API itself should need. We've got a specification, a security set there for bearer auth, and you can kind of see it peeking just at the bottom of that image. We have a query parameter actually set, I believe that's status. So you can go through and just very quickly, GUI up an API. Over on the left-hand side, you can see all the specs that you're working with. OpenAPI is very opinionated in that a single API should have a single set of definitions. So like in our case, we actually supply a whole bunch of different products under various base URLs. So we have a whole bunch of definitions. But for the most part, if you've got one product, you'll have one API, but you can see all of the YAML or JSON files listed out there. And then below that on the left-hand side, you can get an overview of everything that's going on in your current API. So here we can see some paths. There's at least 4 paths in this document that I pulled up from our actual specs. But it also has, you can see your individual models that are being used for your responses and all that kind of stuff. So you can very quickly get this. It's 100% open source, completely free. You can pop it open, start to edit your API. And the nice thing is, it all just generates OpenAPI spec in the background. That's it. You can even go so far as to take another OpenAPI spec and paste it into the code panel, and it will immediately refresh and work from there. So even if you're just using it just to test out some things, to get some of the linting or some of the mock serving, which I'll show in a second, you can just dump stuff in here real quick, play around with it, copy it out to wherever it needs to go. Now, once you start designing the API, user experience is a really big part of that, because nobody loves using an API that's just weirdly named with routes or inconsistent and all that stuff. So you can actually use the OpenAPI tools to turn around and actually prototype and mock those APIs as well. So in Stoplight Studio, there's actually an internal tool called Prism, which is just a command line application. You can either run Prism by itself or it's shipped with it. Down in the bottom right-hand corner, there's this little tiny thing that says mock server that doesn't look quite like a button, but it kind of is. If you push it, it'll actually give you all the routes that are available. So here we can see, just based off of a couple of the routes in here, we've got actually 3 put routes, 2 delete routes. But actually there's a mock URL there that you can actually hit directly with any kind of client and get some output from. So in theory, if I go to 127.001:3100/some UUID/DTMF, and I do a put request to that, I should get some sort of valid thing back. So if I pop open Postman or Insomnia or even just raw curl, I can make a request to a URL. So in this case, I'm going to go to localhost. I'm just going to go to that / base route for our calls. And I'm going to give it a basic authorization header because we have a security setting for saying we have a bearer token. And then down there at the bottom, you can actually see I get a full mocked response. Stoplight Studio and Prism underneath it will actually use the example code that you can put into your APIs. So not only are the examples that you put into the specifications useful from a documentation standpoint, you can actually use it to test your APIs as you start to build them out. So I can see really quickly here, our type in number there at the bottom doesn't have an example. We should probably add that. But we do have examples for UUID and conversation UUID. But this is the exact same API I should expect to get back from my production servers. And you can use anything you want with this. Postman's really great API client just to test things out. One really nice thing with Postman and some other tools like Insomnia, they will actually import OpenAPI specifications too. So even if you're not using this to prototype your own API, you can actually import these things as collections. So I can take our existing OpenAPI spec, import it into Postman, and then I can see over here on the side under collections, all of the different routes, and I can actually play with those. If I couple that with the mock server in Stoplight Studio, then I can actually test an API without having to actually use a production API. In our case, we do things with like voice calls and SMS. I don't actually have to pay for any SMSs if I use the mock server. So we use it a lot internally to build our SDKs. So that way I don't have to actually physically have a phone with me or any kind of other stuff set up. I can pull up our APIs, set up a mock server, and then immediately have something usable, even if I'm on a plane and I don't have cell phone access. Once you kind of have your API set up, you can actually generate API code from this as a developer or even as an end user and start going from there. So there's a bunch of server stubs that you can build directly. For Node, there is an Express one. There's actually two. There's a deprecated one, which I don't actually think works anymore. Last time I tried to npm started, it fell over on itself, but it's actually Merck deprecated. The newest one is an Express app. If you generate an Express app with this, you actually get full controllers. It's all pre-wired for everything. You just need to supply it with data. You can generate the code, do an npm start, and then you have an API that's running. Just you need to supply it with database entries or whatever. If you're not using Node or you have multiple languages you use, you can write them all in OpenAPI spec and just generate out server steps for whatever you want. Most people tend to generate client SDKs with these, though, because we're all fairly opinionated on what our server setup should look like. But if you have you want to be able to supply an SDK very early without having to put in a lot of work into it, you can actually generate client SDKs out of this too. So in this case, there is a tool called OpenAPI Generator CLI, again, completely open source and free. Tell it to generate, give it a YAML file, tell it what language you want. In this case, we're just going to use JavaScript. It actually also has framework-specific code, so you can actually generate TypeScript and some framework SDKs out of this as well. And then an output directory. And screenshots mostly inconsequential, but you can see it generate a whole bunch of code. But if I pop that open in Visual Studio Code, hopefully you can kind of see it there. We get a default API, which is the main entry point for our SDK. We get a whole bunch of models there. So those are the individual response types that we have defined and objects that we expect to come back from the API. But then too, if I scroll down a little bit in here, we can actually see that get calls API. That's the same function that we defined in Stoplight Studio as that kind of just / default route. So here it automatically knows what parameters we have. It knows how to talk to the API. It knows how to set up the authentication. So you can get a very quick and running open client SDK based off the OpenAPI specs. We get a lot of people that use this for languages that we don't directly support, because we support about 6 main languages. But if, for example, someone's using Rust and they need to send an SMS, they could actually generate a Rust client SDK from our OpenAPI spec and use it as their own stuff. We don't directly ship these kind of APIs because they're a little bit clunky, but they definitely work, and they definitely take a lot of the work and boilerplate out of building client SDKs. So hopefully that's kind of a nice quick run through on OpenAPI, why you might want to use it. If you have any questions on it, I'll be around for the rest of the thing, but feel free to find me on Twitter. My handle is DragonManTank, or you can email me, or you can hit us up at Nexmo. But definitely, if you're looking at building APIs, OpenAPI is a great suite of tools to get that kind of stuff done. So thank you very much.
Thanks, Chris. That was brilliant. Looks like we've got one question in the Q&A function. I'm not too sure if you saw it came through. We've got a couple of minutes if you'd just quickly check and answer that.
Sure. Let me find Zoom here again.
Well, just for everyone on, I appreciate you won't be able to see this. The question is, what's the difference between OpenAPI and Swagger?
So OpenAPI is based off of Swagger. Functionally, they are the same. Swagger is just kind of the more commercialized version of it. They supply some tools specifically that they do, but ultimately it's the exact same. It's the exact same specification under the hood.
Brilliant. Thanks. Okay, great. So I think moving on. Thanks again for that, Chris.
Thank you.
Giorgos, do you want to take the reins? We've now got Giorgos from Bet365. So yeah, when you're ready, Giorgos, feel free.
Can you see my screen?
Yes, all good. Yeah.
All right. Hello, everyone. I'm Giorgos Bamparopoulos, and today we're going to talk about web performance. It's quite a big topic, so I will try to cover as much as possible in the 20-minute slot I have. I'm a full stack developer at Bet365 at the moment. You can find me in the social media. I'm working on the sports website of Bet365. I'm also the organizer of the Manchester Node.js Meetup here in Manchester. So if you guys are interested in Node and you're based in Manchester, feel free to come in one of our events. And there are some discussions to host a virtual event there as well. So what is really performance? And we will talk about what performance means to us developers, what performance means to the users of your website or application, and what performance actually means to the business. And there are a couple of myths around performance, and we're gonna help these guys out to bust some of them. The first myth is that the user performance can be measured with a single number. I'm sure you've seen that in Google Loudhouse, for example, where it gives a score to every web page, like let's say 80%, but that's an indication of, and like an average of all the performance metrics. So because in the reality, there are many different metrics that can affect your website's performance. And we really need to look at the entire picture. What are these metrics? What are the metrics that make up your site's performance? And even for a single metric, let's say the page load time, it's not a single score, but it's actually distribution. Because when you have a single score is when you access your web page, you can access your web page, let's say in 5 seconds, but this is not the page load time, because it's really the collection of all the page load times for all the users. So in the image below, you can see distribution. This is a collection of page load times for multiple users in a website. So although you can see that most of the users are experiencing load times under 5 seconds, there are still users that are experiencing load times up to 10 seconds. And from here, you can see that what distribution of a performance metric will look like. So the next myth is that the performance and user experience can be captured with a single user. With this single user is usually us developers when we are working through the apps. So when scientists, for example, want to do research and validate their theories, what they are looking for is basically a representative sample of users in order to validate it. And the same applies when measuring performance. We need more users. And why is that? Because of course there are many different conditions. User conditions can vary highly depending on different factors. So they can vary based on network conditions and connection speed. Is your user browsing your application through his mobile phone and using 4G, 3G connection, or even worse, or from a fast broadband from his house, from his home? Also, the device and hardware also plays a role. It's different condition. So again, if the users are browsing your application through their low-tier mobile phones or their fast gaming computers at home. Browsers also, newer browsers tend to optimize things, JavaScript parsing, and be faster than older browsers, and of course, cache conditions as well. If the user has visited your site before or it's the first time. All of these factors, we have to take them into account when measuring performance, really. One last myth I will talk about is that you only need to care about performance at load time. Everyone is speaking about load time, and myself, I do agree that it's one of the most important factors for website performance. But it's not only that, because users really associate performance with their overall experience in all the journey to your website. And to be honest, bad user experiences can happen at any time. They can happen when the user interacts with your site through clicks, toggling form controls or tabs. sure you all have experienced scrolls and swipes that feel a bit laggy on certain websites. Even animations can feel laggy. So we have to take all these factors into account as well when we discuss about performance. And it seems that it goes beyond that the page load. So now we define some things about performance. Let's talk about testing and how we can measure them. There are two ways of testing. One is called the developer testing, which is done by us during the app development. And one is testing in the real world with real users. They both have advantages and disadvantages. I will name a few. For example, when we're doing the performance measuring and performance testing, it's easier to debug because it happens during development and we developers use the same environment, so it's consistent. But on the other side, it doesn't capture real world traffic, which is what we are interested in more. And also there is a lack of benchmarking. We can't really benchmark the page load times and the other performance metrics with the other side for websites from the same industry, for example, because we will have to go to each one of them ourselves in order to compare the results. From the other side, we have real world testing. Here we can get real world user experience, which is what matters the most. And also we can correlate these performance metrics, this performance result with business key performance indicators. For example, if we use Google Analytics, let's say, and we send all this information there about performance, then for each user, we can correlate the bounce rates, the session times, and all this kind of KPIs that we want. But it's harder to debug because it happens to the user, we are not there. Sometimes it's hard to replicate the exact steps for the user. And also there is some overhead because we need to analyze all this data, and this is some time that we can spend on development, for example. And in today's talk, we're gonna focus on the real world example of how we can capture performance metrics from real users. So user experience, what users think when they visit your website, how do they perceive performance? So Google developers have defined perceived performance and they say that it comes down to these 4 questions. Is it happening? Is it useful? Is it usable? And is it delightful? Is it happening is the first stage, which means, is it happening? Is there any indication on the screen that something is happening? For example, is there any spinner that tells the user that something is loading? Is it useful? At this stage, is there enough information on the screen that the user can consume, apart from the indicators? Is it usable? Is it interactive? Can the user interact with the website so far? And is it delightful? This means that is the overall experience good? Is it consistent? Which comes down to the long tasks, which are JavaScript tasks that take more than 50 milliseconds to load. Let's see that into practice. This is a good example of how an application should look like during page load. So on the second frame, you have first paint. This is the first time that you have something on screen. And this answers to the questions, is it happening? Something is happening. On the third and fourth frames, you have some elements on the screen. You have your first contentful pane and first meaningful pane. This is the time that the user can consume some information, and the most important elements on the screen have been rendered. And then on the last frame, you have time to interactive, which is finally the point where the user can interact with the site. So all these stages really add to the perceived performance from the user perspective. And let's illustrate that by having another example with another page load, which takes the same amount of time to load, but it looks like this. So in this page, you have nothing on the first 5 frames. And at the end, at the last frame, you have time to interact, which is the point that the user can interact with your website. So if those two page loads look the same and did the same amount of time to load, let's say 5 seconds, the perceived performance on the first slide was better for the user, because this one, the user doesn't know if something goes on, and he might leave your page, for example, before you reach the last frame. This is why every performance metric and every stage matters. So how to measure all this? Fortunately for us, there are web APIs that are W3C recommendations, and some of them, they have their second version as working draft. These are performance timeline, user timing API, navigation timing API, and resource timing API. And they can have entries and performance metrics for concepts of navigation, which is the page load, about all the resources for our websites, like images, scripts, fonts, videos, everything. Information about paint, which is first paint and first contentful paint. Long tasks, which, as I said earlier, there are JavaScript tasks that take more than 50 milliseconds to load, and application entries, which are custom entries that we can define, the developer can define to measure 2 points between function call, for example, in the application. So let's have a look at paint entries and see how we can get them. This is first paint and first contentful paint. So in the code below, you can see we call performance.get entries by type. We specify paint as a type, and we get the entries. We loop through the entries, and we console log the name and the start time. And in this example, you can see that the first paint took 1,800 milliseconds, about that, and the first contentful paint took about 1,900 milliseconds. So you can have your code there, gather all this data from the users, and then store them somewhere on your backend side to analyze them later. Next one, and probably the bigger, is navigation entries. These provide data that can be used to measure the performance of a website, and they break down the events required to retrieve and display the web pages and provides timestamps for each one of them. How a typical navigation page load looks like. Looks like this. I won't go into much detail in everything here, but when you request something, when you make a request, you pass all the stages. So from redirects and tapcasts to DNS and TCP stages to the actual request and response. And after that, you have your processing, the DOM processing, JavaScript processing, and the load of your web page. So for each one of these stages, the navigation API, this JavaScript API, provides properties with timestamps. So you know exactly at what time something happened. For example, you can see on the request box, you have request start and request and response start properties that you can have timestamp for. So based on these attributes and these timestamps, we can calculate different metrics. For example, you can see below in the code, we get the navigation entries, performance.get entries by type. We specified navigation as a type. And we want to calculate the total time, the request plus response time, without taking account any caches, just the network. We can do that by subtracting the request start from response end, and this is our total time. Also, we can be interested that the time we reach the first byte, the first byte arrived, we can do that by subtracting request start again by the response start. So we can calculate different and many properties. My advice would be store the raw data in your server, because you might change your mind, might want to calculate more properties or properties differently. So it's worth of storing the raw data if you have space, and then do the calculations later. The next one is the resource entries. These are performance metrics about all the resources, CSS files, HTML, JavaScript files, images, everything. It uses concepts of navigation. It builds on top of the properties from the navigation API, and also includes some more like transfer size, encoded body size, decoded body size, depending if it's encrypted or not encrypted. And with that, you can draw a waterfall with all the resources fetched from the network. Some of you might have seen this one in Google DevTools, for example. Actually, Chrome is using the exact same APIs that we are using to measure performance. And you can see in here, you get the name of the resource, the status, type, initiator, you get the size of the response, the time it took to load, and the waterfall of all the resources. It's quite useful that you can do it yourself. So use cases now, what we can do with all this data. Of course, we can measure the page load, one of the most important factors. We can send all these timestamps to analytics. If you use Google Analytics, that's great. I told you about earlier, you can correlate with business key performance indicators. We can also raise an event if any resource takes more than expected to download. If you have some important resources like a big image on your landing page, for example, you can track that. Raise also for the event listeners, if you want to see about if a user interaction is consistent, you can measure how long it took an event listener to fire by having custom application performance entries in your application. That's pretty much it from me. What's next? The goal is to always be faster. And for that reason, we want to prevent regression in the future, which means it's best, I believe, to test performance both in the lab yourselves and in the real world. You can set up notifications if performance regresses. That's particularly useful in larger teams. So you might want to get notified when the performance of the website regresses. And you can also integrate performance tests in the continuous integration system. So if you're using CI, you might want to have some threshold in the key areas of your website that performance matters a lot, and even fail the build if that threshold and that criteria are not met. Thanks for your time.
Thanks, Giorgos. Again, great talk. We had a couple of questions come through actually whilst you were talking. So not sure if you can see that your end, but also for everyone listening and watching. First one come in. Just like to ask, what's the cost of a single HTTP request?
So what do you mean? What's the cost?
I'm unsure myself. It was from Rafael. So Rafael, if you're listening, I don't know if you want to maybe chuck in the chat clarifying what you mean there. That'd be great. In the meantime, so we had a second question. What libraries are you using for the performance and navigation statistics?
You can use, there are a couple of libraries you can use. There are some that play with Kibana, but we are using at the moment custom JavaScript. You don't have to use any libraries, but there are libraries available that you can use, and they also help you create these charts and waterfalls that I had on the resources page. I can send that to you if you want. That was part of a larger presentation, and I had some libraries there as an example. So I can add this to that so you can circulate to everyone if you want.
Yeah, that'd be great. Thanks again, Giorgos. Okay, thanks everyone. I think that wraps everything up. Just like to say thank you to all the speakers so far, Jonathan, Chris, Giorgos, everyone who dialed in. I think it went pretty well. We're going to be running these every month from here on out, so the foreseeable, virtual, and then hopefully back to normality, whatever that means. So yeah, stay tuned. Jonathan, our first speaker, would just like to mention he's running his own meetup. So that's programmed in pencil. He chucked the link on the Zoom chat. So just www.programmedinpencil.com. So I think that's around kind of digital product engineering, if anyone wants to check that out. But if not, thanks again, guys. Really great to put this together, and cheers. We'll see you all soon. Take care.